Hi, it's me, Tim Dodd, the Everyday Astronaut. How are you guys? Happy, what is it, Saturday? I'm still down here in Florida as I am working remotely on some really exciting things. And we are here to watch an awesome launch. NASA's sending up some payload up to the International Space Station to make sure that those astronauts on board have food and clothes and like everything. So here's what we're going to do. We're going to do what we always do at the beginning of these things, which is I'm going to show you guys the pre-launch preview for this upcoming mission. So I hope you guys can hear me okay. Setting this up from scratch every time isn't always the most fun, but anyway, that's for a different day. So here we go. You can go to everydayastronaut.com. Anytime you want to see any upcoming missions, just go to everydayastronaut.com, click on pre-launch previews. Today's launch that we're about to see taking off in about 30 minutes, about 28 minutes or so from right now, is an Antares 230 plus carrying a Cygnus capsule. So subject to the scheduled time is today, February 15th at 3:21 Eastern local time. It's East Coast. We'll talk about where exactly in a second. That's 2021 UTC. So again, that's actually in about exactly 30 minutes from right now. So for those of you asking, that's how much time we have. Yeah, it is. This isn't our interesting artwork behind me. The hotel. Interesting choice. I wish this was like a rocket. I should have just replaced it with my own artwork. Anyway, the mission, this is NG-13, which is an orbital resupply mission to the International Space Station. So these are, this is the same commercial contract. Actually, this is technically CRS number 2, the second phase of commercial resupply missions, but it's the same type of thing as when SpaceX sends a Dragon capsule on a Falcon 9. This is the other partner that won both rounds of contracts, the first round and the second round of contracts. And so this is Northrop Grumman. We'll talk about that. So yeah, so the launch provider, Northrop Grumman Innovation Systems, previously Orbital ATK. Northrop Grumman purchased Orbital ATK, I think about 2 years ago now. And so this is the, the customer for this is NASA, since these are the commercial resupply. It's a NASA mission flying on a Northrop Grumman rocket and the Northrop Grumman Cygnus capsule. So we'll talk about that in a little bit. The rocket that they're flying on is their Antares 230 plus. I'll talk a little bit more about that here in a second when we get down to the very bottom of this. I'll tell why it's the 230 plus and things like that. The launch location, this is launching out of Virginia. So if you live on the East Coast, there's actually a pretty cool, a pretty decent chance that you'll actually be able to see it today, depending on where you're at. Although it's a lot easier to see rockets launching from far away at night. Of course, this being a daytime launch or an evening launch, it won't be as easy to see. But this is coming from Launch Area 01 from Mars, what is that, Mid-Atlantic Regional Spaceport or something, Mars. They call it Mars Pad 0A is another way that they denote that, and that's right next door. You'll see when we pull up the live stream, you will see that right next door is Rocket Lab's new launch pad, and I just think that's really cool. Payload mass. This is a pretty decent sized payload, 3,700 kilograms, or about 3,500 to 3,750-ish kilograms. So that's about 8,000 pounds. So 4 tons, almost 4 tons, 4 English tons, almost 4 metric tons, around there. Pretty decent, but for only going to low Earth orbit, that's not a ton either. I mean, it actually is 3 tons, but it's not that big compared to some other missions. So these satellites are going to low Earth orbit. So that's, of course, where the International Space Station is. The International Space Station is on that 51.6 degree inclination across our planet. So this will be rendezvousing following that exact, it has to literally line up with that orbit as the Earth spins kind of underneath the orbit. That's why there's this really small launch window, because in order to actually rendezvous with the International Space Station, you have to be lined up with that orbit. And boop. So that's where it's heading off to rendezvous with the International Space Station. So will they be hit? So basically all the rest of this stuff for a little bit is stuff that's more meant for SpaceX launches, but will they be attempting to recover the first stage? They are not, because Northrop Grumman does not do that. The only 2 companies that will ever see that in the future will be SpaceX missions, of course, but also Rocket Lab has started actually attempting to recover their boosters, I believe, getting closer to that step for their next launch. So this will become more and more of a thing, as opposed to right now, if it's not a SpaceX mission, that's always like, no, that's not something that they do. Where will the first stage land? Of course, because they're not recovering it, the first stage will crash into the ocean. Like most rockets crash in the ocean, unless they're launching from Russia or China, then they tend to crash on land. They are not also recovering fairings. Currently, that's only capability SpaceX has developed. But so again, not something that Northrop Grumman has decided to develop. So therefore, these fairings are brand new. So this is the 12th launch of an Antares rocket, the 7th launch of an Antares 230 series rocket, the first launch for Northrop Grumman this year. And here is our graphic by Jeff Barrett. Now, one thing you'll notice, so the Antares rocket it's a really unique vehicle because it's a 2-stage vehicle. It can be flown as 3 stages with various different upper stages. But in this 2-stage configuration that we'll see today, it's a lot like an Atlas V first stage, very similar to an Atlas V first stage. It's dual engines though, instead of a single RD-180. The RD-180 is 2 nozzles with a single turbo pump, so it's technically 1 engine. And those nozzles, it looks like 2 engines, but it's not. This actually is 2 engines, and it always has been. And originally, the original version, the Antares 200 series, flew with literally refurbished NK-33 engines from the Soviet Union. These are 40, 50-year-old engines that had been sitting around, developed for the N1, for the actual moon rocket that the Soviet Union was working on. And a bunch of them got stowed away. And then Aerojet Rocketdyne in the 90s or early 2000s bought a bunch of them and started refurbishing them because they're wonderful engines. They're unbelievably efficient and still a marvel of engineering. And so they bought a bunch of them, but unfortunately in 2014, one of the 2 engines failed after only about 5 or 10 seconds in flight, and it made the whole vehicle come crashing back down onto the launch pad. So after that, at the time, Orbital ATK decided to pursue a different engine, a slightly different engine. It's it's almost like a weird sibling, but it's not really. It comes from Energomesh, and it's the RD-181, which is a single chamber engine version of the RD-180. So the RD-180, like we mentioned, sorry, this is like a whole, you're getting a random history lesson here on the engines. The RD-180 is that engine that's on the Atlas V, and the RD-180 and the RD-180 is already a dual chamber version of the RD-170, which is a 4-chamber engine. So it goes RD-170 4 chambers, RD-180 2 chambers, and then the RD-181 is a single chamber version of that. I know it's really confusing, I'm sorry, but there you go. That's the history, and that's what it has now, and it's actually a slight upgrade. They were able to stretch the tanks and do a couple things and increase. The 230 Plus has a little different fuselage and things like that. So it's a very interesting and unique vehicle. It's fun to see it fly because it doesn't use any solid rocket boosters, and it's just cool. It's different. It's short. You need to realize that at 42 meters tall, the whole vehicle is only about as tall as the first stage of the Falcon 9, while being almost the exact same width. It's about 0.2 meters wider, about 1 foot wider than the Falcon 9, but it's almost the same dimensions as the first stage of the Falcon 9. Just kind of keeping that in mind. I'm going to work on pulling up the live stream here, but I just wanted to say hi. How are you guys? I hope everything's good. I'll get to some of your comments. Oh, thank you so much to Topaz the Meme and Pete Cowles. We do have 2 new members. So thank you guys for your memberships. You're awesome. How's my Discord channel going, guys? Yeah, that is crazy. The N1 would have been nuts. And it would have been the NK-33s to fire. Let me turn off some of the settings here. And I think we're going to try pulling this up here, see if I actually did it right or not. Let me make sure I'm in not potato mode, because auto decides always to give me like 120p. But I'll have this pulled up here. I'll keep answering some of you guys' questions though in the meantime, because we're still a little ways away from this launch. Hopefully the stream doesn't buffer for too long. Ah, there we go. So anyway, and Mbis, thank you so much for your excited smiley face. Nate Erickson, hey Tim, love your videos. Hopefully we have a successful mission, successful launch today. I absolutely expect this, of course, to be a successful mission. This is, of course, Northrop Grumman, who has a lot of experience with spaceflight systems. And their Cygnus capsule is pretty big. Has a
now just under
here. I'm going to listen up real quick.
Away from liftoff, and all systems are still on track for an on-time launch today.
Sweet, nice and easy. Basically, they said that all systems they're looking good for an on-time launch today. That's what we like to hear. So hopefully, we're not going to see any surprises. As you can see on the countdown clock, there were T-minus 21 minutes. So yeah, I'm hoping for a successful launch today, and then tomorrow morning I'm going to be live streaming on site for the Starlink 4 mission down here in Florida, and we're going to be doing the telescope and everything. We really have a lot of things that we're working on behind the scenes again. I know my Discord, I've talked about it quite a bit, but yeah. Oh yeah, we probably should do, I'm wearing the right shirt for this. I am wearing the pointy end up, flamey end down shirt. And based on this footage, I can for sure see a pointy end up. I'll wait to confirm that the flamey end is down once we get maybe a shot of the, get a shot of the engines there. But I can definitely confirm those pointy ends are up. I do want to mention, right now this is a good shot off to the right of the clock. You can see that little black thing. That is Rocket Lab's launch erector, basically, their strong back. So that is the, that's how small the Electron is over there. It fits in that little black cradle there compared to the left of the water tower is the Antares. And the Antares is not very big in general. I mean, it's, again, only 45 meters tall compared to, or 43 meters, something, it's under 45 meters tall. And then compare that to right next door, the little itty bitty Electron, and it makes you realize just how small and cute it is. And yet the Electron is actually going to the moon here soon. For those of you watching my stream, if you pull up NASA stream, yes, mine will always be behind NASA's because I'm bringing NASA stream in, and then it gets restreamed out. So there's always about a 20-second delay between all of those things. So yes, I'm aware that my feed, it's behind. It's just the speed of light and or ingestion settings. If you want to see real time, go ahead and pull up the official stream. I won't take offense if you need those extra 20 seconds. Go ahead and take them. Take them. Yeah, I guess mine might be a full minute. Whatever. Take that minute. Turn on subtitles. The subtitles won't really do much, to be honest, I don't think, because they're going to be in real time. But we can try. I've never actually tried that. This might be spooky. I just can't imagine, unless they're paying for real-time subtitles. We'll see. I don't know. So thanks again to Nate Erickson and Green Axis Space Agency. Really enjoy the coverage you do. Thank you so much, Green Axis. I appreciate when people have a little grace. I definitely kick myself a lot when things are, when things are don't go as planned for me, which is why I'm working on some really cool setups and some big changes for stuff down here in Florida. But Ming Lord says, hey Tim, need to speak to the Astronomy Live guy. He uses the telescope on rockets. Got amazing footage of Falcon Heavy. Hey Ming Lord, where do you think I got the software to control the telescopes? If you aren't watching my Twitter feed, I talk about it all the time. Scott Ferguson from Astronomy Live has done an amazing job of taking telescopes and making it so his software can run them with joysticks, and so the software can also track things in the sky. So that's who I worked with actually to make it so the telescope works to be able to use it as joysticks. So we're working on a whole rig eventually where we're going to have 2 telescopes and they're going to be controlled by joysticks. And our friends at OPT Telescopes out in Vista, California have helped us out a lot. And they're just like, here, use these, do cool stuff with them, which I'm like, game on. Challenge accepted. I will absolutely love to do that. So yeah. Mouser, membership, awesome. Thanks for the membership. Is behind... Oh, yeah. Yeah, Joey S4B, of course. NASA stream is always behind real time, and my feed is even further behind. That's just how live streams work. Live streams are never real time. Even old satellite trucks. Remember, like, when they're like, all right, now off to you, Jane, and she'll be, like, sitting there out in the field. Thanks, Rick. And it's always, like, this, like, weird 4-second delay. It's just, that's how, even a satellite feed has a substantial delay. So these days, though, using the internet, 15, 20 seconds of latency is pretty normal. But yeah, M or B3 Bernard, basically. I'm in Miami this weekend. I was wondering where I should look for the rocket launch. So Bernard, if you look up the coast tomorrow morning, let's see, SpaceX is launched. So tonight you won't be able to, or today's you won't really be able to see it since it's launching from Virginia. You'll be too far away. But tomorrow, let's see, what time is that one? I got to set that stream up for tomorrow. Tomorrow, I'm just pulling up the Next Spaceflight app on my phone. That's one of my favorite ones, run by Michael, and with NASA spaceflight stuff. This app just keeps getting better. It's definitely my favorite one for knowing this and SpaceX. SpaceX Now, yeah, SpaceX Now is the other good one too for SpaceX stuff. But if you want kind of all of them, this one seems to be pretty darn good. So tomorrow's launch is at 10:25 a.m. Eastern. So if you're in Miami, look straight up the coast basically, and there's a good chance you'll see it from Miami, but you won't see it for about 15 or 20 seconds because of how long it takes for it to clear your horizon because you're so far south. But yeah. And also, Vipercrest, thank you so much for the donation. So yeah, isn't that shot really does show you an awesome comparison there between the Antares and the Electron rocket. See, this is why I don't this is why I didn't want to have captions on there. CMD, you go to transfer signals. Okay, I'm going to listen in here. I do want to hear this stuff. But I'm going to turn off the closed captions because they're just automatic and they're kind of cabbage. So let's get those out of here. All right, let's listen and see if we're going to get any cool, like, go, no-go countdown. Bernard says, or should I go down to Kennedy Space Center and say hi? Well, I will be behind the gate, so if you come to Kennedy Space Center, you won't find me, unfortunately. I'll be streaming from the causeway, only about 2.5 miles away from tomorrow's Starlink mission. If you want to see a rocket launch, though, the closer you can get, that's definitely the better.
And we're at T-minus 15 minutes and
My
counting.
placement looks weird there. Since they have their own.
Core 1 on countdown 1. No fuel adjustment is required.
Copy, Core 1. We'll check step 383, prop 2. Configure OCCS for no adjustment to fuel level.
In work.
Okay.
And prop lead, perform, step 385 will not be required.
Sweet. I am seeing it looks like the flamey.
Prop 2, OCCS configured for no adjustment to fuel level.
Copy that. We'll check 384 complete.
The flamey end was definitely down. Look at that. I can tell there. Pointy end up, flamey end down. Great shot.
And launch team, we're about 2 minutes away for our final poll. We'll proceed with our final countdown today.
Camera 12 is my pointy end up, flamey end down one.
Ops 2, LC, countdown 1.
Go ahead, LC.
Let's go ahead and initiate step 387. You can initiate FIV position override.
Override complete.
Copy that, Ops 2. We'll check 387 complete.
So let me answer a few more questions as they're still preparing to actually get this. And we'll listen in for the
Standing by now for that 12-minute mark before launch, where flight controllers will conduct a poll to proceed with the final launch countdown.
Okay, so at T-minus 12 minutes, we'll listen into the countdown clock. But I wanted to point out a few things. Marshall, I hope I watched the Tesla since the Dragon in flight abort test. I love the stream. There's a lot of fun. Thanks for all you do. Marshall, don't tell my dad, but I haven't watched the Tesla yet, and it's killing me. That was actually on my to-do list today, but I was running around doing some stuff and just didn't make it out there. But tomorrow for sure. Tomorrow after Starlink, I think the Tesla deserves a really, really good detail. So it'll be the day tomorrow. Look at that. That's a pretty shot there. It's a gorgeous day again. It's not as pretty as it was when it was supposed to launch last week. That was a beautiful night. Really a shame. But Paul Jr., hey, how's it going? It's been a long time since I had a chance to catch an Everyday Astronaut live stream. Always a pleasure. Keep up your awesome work and stay overreactive. I can't help that. It's kind of a sickness at this point. I'll always be overreactive. But Paul, thank you. You've been around for a long, long time. I'm glad to see you back in the stream. And everyone say hi to Paul. He's been around for a long time, and now my picture-in-picture is a picture-in-picture-in-picture. Okay, we'll listen in here in a second. And Bernard, what was the app? The app, there's two really, really great apps that I use all the time. And there's Next Spaceflight, definitely available on iOS. I don't know if it's available on the Google Store, but Next Spaceflight's awesome, and so is SpaceX Now. Both are really good apps, and yeah, they're really, really good. But the SpaceX one is only for SpaceX launches, so if you're only tuning into the SpaceX launches, use that one. But if you want kind of all of the other ones, check that out. So, all right, I'm going to pull up the volume here because I think we're getting close.
Space exploration will inspire generations of people from all backgrounds to reach for the stars. Northrop Grumman is go.
And I copy that, NG. We'll go to proceed with final countdown.
Sweet.
And launch team, be advised, step 389 will not be required, and step 390 will not be required. Step 391 will not be required.
Sounds like I didn't think we missed it. Sorry.
You just heard the poll to proceed with the final countdown to launch, and all teams are a go.
That's awesome. Good. I hope this thing goes off today. They've had some scrubs with weather. I think the weather they scrubbed yesterday because of weather, and I think that same weather that they scrubbed for yesterday is why SpaceX isn't doing. They were supposed to launch Starlink today, but they scrubbed because of the weather they scrubbed for yesterday would have made recovery today difficult. So they scrubbed to tomorrow. So now tomorrow hopefully should be a clear day for recovery as well. Isn't that crazy that SpaceX scrubs and has no-go if...
Just under 11 minutes now from launch, and everything is still proceeding smoothly for an on-time launch at 2:21 p.m. Central Time, 3:21 p.m. Eastern. Once we get to that launch time, the first thing that will occur is the Stage 1 ignition, and you'll see liftoff just a few seconds after that. And those two main engines will burn for about 3 minutes and 28 seconds before cutting off, and Stage 1 will separate. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate.
LC countdown 1, we're going to go ahead and perform the main engine FIV opening checklist. You are go to proceed on steps Q1, Q2, and Q3.
And altitude copies. Opening VZD on my mark. 3, 2, 1, mark.
Mark.
And IR time 20:10:52.
Copy Q1.
Sweet. All right, things are looking good. Proceeding smoothly, it appears. Yeah, so hopefully you got that app, okay, Bernard. Don Banks, without you reassuring us that the pointy end is up in its correct orientation, we'd be lost. You're welcome. How would they do it? It's beyond me. The Elon Gamer, hey, from Boca Chica, can see new serial number 1 rings. Yes, there has been, I talked about this on my podcast. So again, people always ask me, like, Tim, why we want more content from you, because a lot of the content I work on takes me like months, like this one that I'm working on right now. I just finished the script, or had it sent out after I did the speech version of it. Script's ready to go, but it's about how much do rockets pollute, because you can see a lot of smoke coming out of them. So I tell you exactly what comes out of a rocket engine, exactly what are those is like pollutants, what's toxins, what's greenhouse gases. It's a really interesting video, and it's been a research nightmare because it's one of those things. There's not a lot of research out there on that. Well, there is, but it's just really hard to find, and so it's been a long one. But for those of you that always are like, Tim, we want, why don't you do a video once a week or more and more? I do a 1 hour podcast every single week, but not on this channel. It's a joint podcast that I do with 2 other guys. It's called Our Ludicrous Future. Please subscribe to it, Our Ludicrous Future. We just did episode, I think, 71 or 72, so we've been doing it for over a year. I talk space news for about 20 or 30 minutes every single week. So if you want like my feedback on things like the serial number 1 rings that are looking fantastic, or if you just want to hear more thoughts on, I always talk about rockets. We always talk about EV and just futurism in general. So if you're into like electric cars or all those types of things, definitely subscribe to Our Ludicrous Future, either on YouTube here or on your favorite podcast, because we also make it audio as well. So audio or video, whichever one you prefer. So. Let's see. So DJ Midman, thank you so much for the new membership. You're awesome. Speedster 338. Finally, I catch a live stream. Keep up the great work, man. Love your in-depth videos and launch streams. Even though I never catch them live, I still watch them all. Well, hey, you're catching this one. Much love from New Zealand. I love New Zealand. Thank you for saying hi. I can't wait to make it back out there. I absolutely will for sure be making it out to another Rocket Lab launch or an actual Rocket Lab launch someday. Unfortunately, I'm guessing just because of scheduling and stuff that my first Rocket Lab launch will be here at Wallops, right next to this rocket, as opposed to seeing one out there in New Zealand. That's definitely my dream. But yeah, New Zealand is gorgeous. But yeah, so again, just another quick shout out and reminder for those of you that want more content, you want to hear more from me, don't forget to check out Our Ludicrous Future. Hopefully you clicked on it right now. Hopefully you pulled it up on YouTube. Hopefully you got out your phone and subscribed to the podcast. It's a lot of fun. It's a lot more casual. It's just kind of talking and explaining things. But it's one of those things that's good if you're listening, if you're waiting for like a commute or something like that and you have a weekly thing. It comes out on Fridays. So it's a good end of the week little rundown on what all happened for the week. So hopefully you guys want that. So yay. Oh, this is a good question from Christian Cortez in our chat. Christian. So Christian asks, what's the difference between serial number 1 and Mark 1? So it is kind of confusing because we've seen Starhopper. That's like pre-serial numbers or Mark 1. Then the next things we were seeing built were called Mark 1 and Mark 2. Mark 1 was the prototype being built in Boca Chica, and Mark 2 was the prototype being built in Cocoa Beach. And basically what they were doing is they had two teams employ slightly different techniques on how to weld and how to actually stack rings to manufacture a Starship, right? So they had two teams. They were kind of competing a little bit, but come to find out they were never really flight worthy, even though I think Elon kind of touted that the one that we saw at the Starship presentation at the end of the year, or in September, whenever that was, he kind of touted saying this is going to be the one that's going to fly, when it, come to find out, wasn't anywhere close to flight ready. So now the one they're building right now, they would have been like Mark 3, but they decided this is actually serial number 1. This is an actual, they're preparing it for flight. It is truly like a real one. So now it's just SN1, serial number 1. So before we saw Mark 1, Mark 2, this would have been Mark 3, but because they're kind of making it, manufacturing it now, then they are now calling it serial number 1. So from now on, we'll basically always be seeing serial numbers. So that's the difference. Really good question. Really good question. I do want to say YouTube, Trap Astronaut says YouTube community is the best community ever. I have to agree with an asterisk. It's the space YouTube community is awesome. We're really fortunate. I really like space, especially like the people on my Discord channel. You guys are unbelievable. But I really think that the space community on YouTube is one of the best communities out there because people are excited. We all want to learn together. We all want to watch spaceflight together. So, yeah. Let's see. I'm going to listen in real quick, make sure we're not missing anything.
LC Ops 1, FTS on loop open and green.
LC Elect 2, FTLU and FTS receiver indications are nominal.
Roger that. Elect 2, Ops 1, step 404. Send all armed command.
LC Ops 1, all armed command sent.
LC Elect 1, SNAs, ODMs all armed. Copy. Elect 1, we're at T-minus 4 minutes and counting.
Sweet.
NASA TD, report range status.
Range is green.
Good. That
Roger
means
that. TD, range is green.
No boats or airplanes downward.
And launch team, be advised, step 407 will not be required for today's operation.
Okay, so everything's looking good. Still tracking for an on-time launch. We got about T-minus 3.5 minutes. So Adnan asks,
And we're passing T-minus 3 minutes.
Adnan asks, will Raptor be as accurate as Centaur has been? So
T-minus 3 minutes.
the accuracy of Centaur is unbelievable. But I'll almost say no in a sense. It's not necessarily about, well, yes, but no. One of the reasons that Raptor or that Centaur can be so accurate and their insertions can be so perfect is because it's actually very low thrust. Therefore, ramping it up to full thrust, even then, say you have an 8-minute long burn, or if you have to do like an insertion burn, it's over several minutes maybe. It might be like a 2-3 minute burn, where sometimes we'll see Merlin do like a 2-second burn, or sometimes we literally see 1 second of the Merlin. And Raptor's twice as powerful as Merlin. So when it does actual insertion burns, because it's a lot more powerful, those to get up to speed is like. So in a sense, it's not necessarily about accuracy, but there is a lot more wiggle room when you have a lower thrust to weight ratio, because your insertion burn is a lot longer time. So you have, and Peter Beck, I talked to Peter Beck right there, sitting on that launch pad right there that you guys are seeing, the CEO of Rocket Lab. I talked to him. Check out that interview if you want to hear more about this. But he's talking about how good it feels because the Electron has such quick startup and quick shutdown transients, and it's so accurate that they just absolutely, and because it's a fairly low thrust to weight ratio, they can just absolutely nail. Or it's with their kick stage. Their kick stage, sorry, is so accurate. They can just perfectly insert their payloads really hyper accurately. The other thing though is you can make up for, so the main engine burn, you can do that, but then you can use RCS to really fine tune your orbit and make sure you're really dead on. The Centaur can do that, of course. The Centaur has RCS thrusters, and so will Starship and other vehicles that would use, say, Raptor, or vehicles that, if that makes any sense. So
T-minus 1 minute.
all right, time to listen in here. T-minus 1 minute and 30 seconds. Well, they did say T-minus 1 minute. Is the clock off for their clock? Maybe. Okay, we're getting close. let's listen in here. Well, the latency, the video and the audio should be...
And T-minus 1 minute.
Okay. Now
Mark.
Didn't he just say that? I'm a little confused, but hopefully they're not. Ooh, I'm seeing some really good questions. And I'll get to you guys' questions. I'm going to be listening in here for the last minute. I'll get to you guys' questions here after the launch. And
40 seconds until liftoff.
we'll stick around a little bit. So,
T-minus 30 seconds.
okay, here we go. T-minus 30. This is the good stuff. Get ready, guys.
20 seconds till liftoff.
I'm going to put my face over here. All right, baby, it's looking good. So first we'll see that water dating
T-minus
system.
10,
Right about now. Fire up on the water.
5, 4, 3, 2, 1.
Engine start. Liftoff Antares, NG-13 mission with Wallops Flight Facility.
There we go, baby. Good.
Engines at 100%. Attitude nominal.
That's a cool little
TVC
rocket.
nominal. Core pressures are nominal. Engine chamber pressures are nominal. Attitude nominal. Power subsystem nominal.
Yeah.
Altitude 10,000 feet. Attitude nominal.
3,000 meters.
Core system performance nominal. Engine and TVC systems nominal. Velocity 1,100 feet per second.
Wow.
Attitude continues nominal.
It's looking good.
Max Q, attitude nominal.
Sweet. That maximum
Power
aerodynamic
subsystem
pressure.
continues nominal. Altitude 50K feet.
50,000 feet. So 15
Engine
kilometers.
steady, 100%. Core BNG3 activated. Attitude nominal.
Love watching the plume now. Just get wider and wider.
3,000 feet per second. Attitude nominal.
Coming up on 2 minutes into the flight, they've passed maximum dynamic pressure on the vehicle.
Engine and TVC system remains nominal. 100,000 feet altitude.
2 minutes into flight.
Core pressures nominal. Engine steady, 100%.
Looking good.
A minute and a half to go in first stage performance.
It's a long first stage
Attitude
burn.
nominal. 150K feet altitude.
Again, very similar to the Atlas V.
Engine steady. Pressures nominal. $8,000 feet per second. Core pressures are nominal.
It's looking good.
Engines at 100%.
Coming up on 3 minutes into flight.
Low throttle down initiated. MECO slew maneuver initiated.
Yeah, whatever you do, do not play
Attitude nominal.
a nominal drinking game because you will not make it through the end of the stream, I don't think.
Engines at 55% and nominal.
Nominal's good. Nominal's better.
14,000 feet per second. Main engine cutoff.
Main engine cutoff confirmed. Standing by for stage 1 separation.
Upper ACS enabled. Stage 1 SEP.
All right.
Stage 1 separation confirmed. The next milestone is fairing separation, which will come in about 40 seconds.
Altitude 100 kilometers.
62 miles for those metrically impaired. Now we actually have
15
some
seconds to stage 2 ignition.
telemetry, finally.
Fairing separation confirmed.
Bearing separation.
4 minutes into flight.
Interstage separation.
Interstage separation confirmed.
Attitude nominal.
There we go.
Stage 2 ignition.
And stage 2 ignition is confirmed. Stage 2 is that solid rocket fuel that will burn for about 3 minutes and 43 seconds. Burnout will come about 7 minutes and 9 seconds into flight.
Stage 2 will
Okay, so I think this is a good time to remind you guys that the upper stage of this vehicle, this is very unique. It has a solid rocket upper stage. So it's very backwards from what you'd think. Normally solid rocket boosters are kind of used on the first stage where a high thrust to weight ratio really, really matters. This vehicle's the opposite. It has a solid rocket upper stage and a liquid fueled first stage, which is just unusual. But then again, Northrop Grumman / Orbital ATKs definitely, they know how to make a good solid rocket booster. And now before we continue, I should also mention that what we're seeing right now, that is, although it looks like a little Kerbal Space Program animation or something, that's not actually an animation. It's real time. It's taking the real time telemetry and the real time feedback from what what they're receiving from the rocket, and it plays it back so we actually get a good visual reference of what the vehicle's actually doing. I still debate whether or not I'd rather see this versus the cameras. I really like when SpaceX shows us the cameras on stage. But I also like when Northrop and Atlas and, Northrop, ULA, Ariane Space, they all do this visualization where they play the real time. You even get to see the RCS thruster firing. That's what that looks like. That's mostly trying to control roll right now because it's coming off at one of the ends, so it's trying to make sure the vehicle's not rolling. So dampening the roll. But everything's looking good so far, and it's very, very unusual that. Did they just say stage 2 burnout? I'm going to listen in here now.
6 kilometers per second velocity, 183.
If you've played Kerbal Space Program, you might be familiar with some of these things on screen, but one of the things that's fun to look at, notice the perigee right now. So there's the orbital parameters tab over there. Like this. I don't know. It's the apogee in kilometers and perigee in kilometers. The apogee is the highest point in the orbit. So when it's arcing like this, and the lowest point is its perigee. So when that apogee or when that arc still intersects the Earth, that's when the perigee is negative. But as you speed up at the upper spot, what will happen is that the arc will continue to grow out until it actually encompasses the Earth, and then your highest point in your orbit will still be your apogee, and your lowest point will start to grow and grow and grow, and eventually it'll actually flip. If you keep accelerating at that same point, all of a sudden your rocket will be at its lowest point, and the orbit will raise and raise and raise. So you're always raising opposite of where you are. It looks like they had burnout. Hopefully that's good. Let's listen in for a
Stage 2 burnout.
nominal.
Stage 2 burnout confirmed. Cygnus now moving about 16,822 miles per hour.
ACS enabled.
Man, that gets there in a hurry, I feel like.
Beginning maneuver to acquire payload separation attitude.
Things are looking good.
Power nominal. The vehicle will continue to coast until conditions are met for payload separation.
Sweet.
Cygnus separation will come about 9 minutes and 4 seconds into flight.
Attitude nominal, roughly 1 minute to payload separation.
Okay. I always forget that on the East Coast there, when they're launching from Virginia, they're going to launch on the descending nodes. That means, the orbit, on one end of the orbit, you're going up if you're at 51.6 degrees, but on the opposite side of the Earth, you're going down to catch that same exact orbit because the orbit's at an angle. So So on the way up, so Florida, when you launch the International Space Station, you fly up. That's the ascending node. So you're flying northeast up the coast at 51.6 degrees, actually about 45 because they had to account for the rotation of the Earth. Here, if they flew at that steep of an angle, you'd likely be flying over cities and things. So they actually, in this case, will launch it southeast on the descending node. And I just think that's cool. I kind of forget about that. So, yeah.
Vehicle subsystems continue to operate nominal. Roughly 15 seconds to payload separation.
Someone's calling in. Hello, we're taking our first caller here. This is Jim. speaking.
Welcome to
Attitude nominal,
Verizon
heading
Wireless.
into
The
separation
wireless
event.
customer you called is not available at this time. Please try your call again later. Announcement 1, switch 170-3.
Is that on my that can't be
Payload
mine.
separation.
Welcome to Verizon.
And spacecraft separation.
Called is not available at this time. Please try your call again later. Announcement 1,
Beginning
switch
C-cam maneuver.
170-3.
That's not me, right? Like, that can't be... What? What the heck is that? Okay, well, I can't wait to replay their stream and figure out whether or not that phone call was somehow on my end, or if NASA just had someone calling in for pizza as a celebration thing. That was awesome. Oh, that was really great. I like how now it's gone silent. They're like, oh, guys, someone's on the line. And now they're silent. That's funny. Well, everything's been looking great. Congratulations, Northrop Grumman, on a beautiful launch. That was perfect. Everything looked absolutely bang on. And it's cool to see the Antares launch. It looks like the Kraken, or the Kraken or Kraken? Always Kraken. Yeah, it looks like the Kraken's taking hold of the upper stage there a little bit. Yep, everything's okay here. What is going on? Oh, yeah. Oh! What?
And Cygnus is now on its way to the International Space Station, where it will arrive in 3 days on Tuesday, February 18th. I'm still joined on console here by Chad Davis of Northrop Grumman.
Okay, well, let's
Chad,
answer some of your
what will the Northrop
questions.
Grumman
That
teams do
was...
here on the ground
I
until Cygnus
wanted to
arrives
see
in
more
CC?
of that. That really made my day. I wish they had just kept that up on screen. Oh, hopefully the rocket's still okay. Hopefully that wasn't the telemetry being like, oh. But everything looks pretty good, so everything's normal. Kraken, yes, not Kraken. Kraken. Oh, that was a fun one. Let's answer some of your guys' questions here. Let's see. So, Adnan, I hope that answers your question about whether or not this one will, or about how accurate the Raptor is. The accuracy thing, thrust. I mean, all rockets have these transient periods of ramping their thrust on and shutting down. After you shut down, there's always some residual thrust for a little bit. So there's always going to be something, but it's for the rocket companies to account for all those things to make sure that the vehicle is so accurate, right? And it's really not a matter of the engine, because all engines have these variables. It's really a matter of the rocket company knowing these variables, plugging them in, making sure that they account for them. That's how accurate you end up being. So, and again, upper stages normally have some kind of RCS, so once they get in their initial orbit, they can kind of fine-tune their orbits just using RCS to be very, very, very accurate. Hopefully that answers your question, Adnan. Thanks for saying hi. Benjamin Wood, just wish this one could land. I really hope that 2030 we see the phase out of expendable rockets, because I really think a lot of companies, you can tell, are starting to really get into the reusability game now that SpaceX has had so much success with it. I would really like to see that become way more normal. Like, hey guys, listen, obviously this is working for them. It's the 21st century. You know, why aren't all of our rockets reusable? And yeah, I hope that we see more and more of that. For some reason, it looks like the guy in Mission Control, I thought he was wearing one of those like beer hats. What is he wearing? Oh, that's awesome. It's a Cygnus hat, because those are the solar panels. Okay, that's my new favorite person. Cygnus hat man, you're my favorite. That's awesome. I do call the Cygnus the flying space keg, though, because it just looks like a space keg. That is so cool. I love that. Oh, touche. You win the internet today, sir. But thanks, Benjamin Wood. Baker M1972, keep up the awesome work. Love the channel. Thank you so much, Baker. Greg wants to know, didn't they scrub one here last week because some butts got into the range with a little airplane? No, it was not a range issue last week. It was a ground systems issue. Likely the water deluge or something. But the weird thing is I didn't even see the water deluge system turn on today, which was confusing, because I'm pretty sure there's normally a pretty massive water deluge, like water spray down that hoses the pad and makes sure the rocket doesn't completely destroy the pad at takeoff. I thought it had one, and they had some kind of pad errors around T-minus 4 or 5 minutes when they were supposed to launch last week. It wasn't a range issue, but yeah. So thank you, Greg. Ben, I usually listen to our Ludicrous Feature on Saturdays when making pizza for your family. Keep up the good work. That's awesome, Ben. Thanks for listening in, and that's cool. That's a fun tradition, making pizza with the family, listening to three jabronis talk about space and stuff. Thanks for tuning in. That's awesome. Tell your family hi, and hope they enjoy their pizza tonight. Unless, well, where are you? Czech Republic, you probably already had your pizza tonight, so I think that's the CZK. Hopefully, yeah. Say hi to your family, and thanks for tuning in. Let's see. Boom, boom, boom. Usually, Derek, SP, Cygnus can sometimes be seen from the ground before it docks with the ISS. If anyone has a nighttime pass of the ISS in the next 2 days, totally go check it out. That's a good call. I should probably get that telescope that we're running to go out and actually see if there's any ISS passes in the next 2 days, because that would be a really cool thing to see the Cygnus catching up to, because it is very reflective. So you're absolutely right. That would be a fun thing to see chasing the International Space Station. Maybe we could track the two objects and actually do that. I think that'd be pretty amazing. So good call, Derek. Thanks for saying hi. Anastasia, thanks for the membership. You're awesome. DJ Midi Man. Tim, what are your biggest hopes for the space industry in the next 25 to 50 years? You're not talking 5 to 10, 25 to 50 years. Where would you like to see it? Where would you like to see it by then? Think you will stream still? I'll be streaming on holograms by then, baby. I don't know what 25 to 30 years will be like. It'll all be Neuralink, and I'll just be hanging out with you in your living room or something in person, because Neuralink will tell you that I'm just sitting next to you telling you about rockets in person or something. That's my guess, is that I'm serious about that type of stuff. I don't think that's outside of the realm of possibility of technology in the next 25 to 50 years. Seeing that 10 years ago, 15 years ago, we would have laughed at the idea of what this thing can do. Seeing what's going to happen in 25 years, 50 years from now, yeah, there's a very good chance if I'll be old, in 50 years I'll be basically 85 years old, so I'll be a grandpa, just this old guy just hanging out in your living room telling you about spaceflight. At least in your visual cortex, at least in your brain, that's what it'll be, because of Neuralink and things like that. So that's my guess. That's for me. If you asked about me streaming, but the space industry. Sorry, to go about the space industry. Here's what I think is going to happen in the next 25 to 50 years. I think in 25 years we should easily have a permanent habitable presence for sure on the moon, and likely developing one on Mars. And I think in 25 years we'll have actual valid commercial options to be able to go visit the ISS, or not the ISS, but other orbital hotels. Because once the cost of spaceflight comes down by 2 orders of magnitude and gets to the point where 20, 30 grand you can go spend 2 weeks in space, I know that's a lot of money, but for a once-in-a-lifetime trip compared to 80 million, or once it's down to under $100,000 to be able to spend some time in space, I think that'll be a big industry. There's a lot of people that would love to do something like that. If Starship gets to the point where it's flying for $5 million a piece, can hold 100 people on an orbital mission, what is that, 500,000, 50, wait, that'd be $50,000 per person, basically. Well, the vehicle costs, I don't know. Bad at math, don't judge me. But yeah, 500, yeah, that's right, 50 million for 2 orders of magnitude. So, I mean, maybe for under $100,000, you could hang out on a Starship cruise for a week or two and just come back down. I think that's well within the possibility of 25 years. I think there will be a lot of heavy industry in space, as we're working on removing. Jeff Bezos talks about that a lot in his Blue Moon speech last year about their lunar lander they're working on. He really believes that heavy industry should be moved off this planet. That we should basically put a bunch of resources in space to do with the heavy mining, a lot of the high energy consumption, the things that pollute our planet. The steel industry alone accounts for about 8% of global CO2 emissions. Things like that. Move that up into space, and who cares then? Get it out there in orbit around the moon or something. Eventually, there might be like a smoke ring around the moon or something, but it won't matter, and we can keep our planet preserved as a nature preserve, or as a lot more how nature had intended for our planet to be. Keep it as like this little sanctuary. I like that idea, and I can see that being in 50 years beginning to become a reality, where we have moved a lot of those large things into space, and they stay there because a lot of us live in space. And maybe not in 50 years, but maybe in 100 years. That's where I think sorry, that was a long rant on where I think the space industry is going, but I'm definitely thinking like far future on that stuff. There's a lot of big possibilities. And the crazy thing to remember is two of the richest people in the world. Think about what the billionaires of the 1800s, they were working on railroads and oil. And now, in the 1900s, a lot of the richest people were chasing the internet at the very beginning when it was just a bunch of phone lines connected to computers. And people were like, what the heck is this? Right now, you have two of the richest people in the entire world putting a lot of their fortune into the space industry. And when that happens, and when they're actually competing, and when there's actually people investing into the space industry, something's going to happen. We're finally going to break those thresholds that made it unattainable and made it so we couldn't really get into the future in that sense. That's why whenever I come down to Florida here and I see these big changes around the Cape Canaveral area, I just keep reminding myself, yeah, two of the richest people are investing billions of dollars in this area. Something's happening. Something's going to happen. And this, whenever people that are that successful, I'm talking about Jeff Bezos and Elon Musk, when they're that successful and they clearly are seeing something, seeing a trend, and they're chasing it with a lot of their fortune, I think you should probably be paying attention and realize, oh, this is where we're going. That's my thoughts. Good question. Thanks, DJ Midiman. Galaxis, thanks for the tip. Bob, thank you also for the red thumbs up. Very cool. Big fan. Philip says, flamey end everywhere at the end of the stream. That was a full-blown flamey end everywhere situation. I don't know what exactly that was. That was a bit ridiculous. Thanks, Philip. Niels, hi, Tim. It's been amazing seeing you grow as a person, entertainer, and educator. Love your videos. Keep up the good work. Thank you so much, Niels. That actually means a lot. I feel like a lot's changed. If you look at where Everyday Astronaut began as some just weird guy in a spacesuit running around taking pictures of himself, a lot's changed in the last 5 years. So thanks for saying that, Niels. That really means a lot. Derek SP, 2030, end of an expendable rockets. Lol, 2030 is probably when the SLS flies, dropping billions of dollars straight to the fishes. Derek, I think by 2030 it will be very obvious, though. We'll have 10 full years to flush out reusable rockets. And I think SLS is going to fly by 2022, or by the end of 2022. I think it likely will actually fly fairly on time for 2022. It's being tested right now as we speak. Everything will pretty much be ready to go. The upper stage has been sitting around hanging out for years. I saw that 3 years ago. A lot of things are ready to go. The upper stage is literally off of a Delta IV with a payload adapter, or a adapter to make it fit. But yeah, I think SLS will fly, and I think eventually it'll come around to where people are like, we should probably just put this on Starship or New Glenn and New Armstrong and some of the other upcoming vehicles, just because it's way, 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 way cheaper. So I do think that expendable rockets will kind of be phased out by 2030. But thanks for saying hi, Derek. John Hollerman, now someone needs to make a keg with solar panels. I'm sure it's being done right now. That's funny. Jacob, I just interviewed at Northrop Grumman 3 days ago. That's awesome, Jacob. Good luck with that. Best of luck to you. I hope that you get hired. They would be an awesome company to work for. They do. One of the things I'm most excited for Northrop Grumman is they're actually working on a satellite, a service satellite, and I believe it's launched already. And I think they're going to go. The idea is if say there's a satellite up in space that's defunct, but they could extend the lifespan of that satellite by launching this kind of small satellite that just has its own propulsion and its own solar attached to the engine bell, the small tiny engine bell of the defunct satellite. Start guiding and pointing it and re-maneuver it to be able to be active again. And it seems weird, how could you do that? But if they can make a bunch of those little service things a lot cheaper, say, I don't know, $10 million and launch it for $100 million, and you have a $1 billion satellite, that might be worth it, and potentially servicing satellites and refueling them someday and things like that. That's a future that I'm really looking forward to, where we're reusing spacecraft instead of just creating more and more space debris. So very cool. Good luck. I hope that you get hired. Northrop Grumman, I don't know anything about Jacob, but hope we see you in there, Jacob. That's awesome. Bob Arian, great stream and nominal launch sponsored by Verizon. Greetings from Czech Republic. Did anyone figure out, hey, my Discord channel, was that actually in the YouTube stream from NASA? That wasn't on my end, right? I don't know how it could be. I don't have anything connected like that at all. I definitely wasn't dialing into anything. So let me know, guys. That was some funny stuff. Very cool. And greetings from Czech Republic. So yeah, CZK. There are a lot of people from the Czech Republic that tune in. Hi, Czech Republic. I almost made it to you. I was in Austria last fall. I still really want to make it over to Europe to do like a small speaking tour, do like, I don't know, 8 of the more popular cities that I can see from my. That's what's so funny is I'll use analytics to figure out where would make sense for me to go in Europe and or the United States. And I know that people will be like, come to some tiny town in, you know, in Germany. And I'll be like, well, no, I'll go to the big places where there's a lot of people and you come to me. Like, I'm not going to, no offense to, I don't know, some tiny town. Like, I live in a small town, so I'm just used to it. Like, if a comedian or a band's touring, I don't expect them to come through Cedar Falls, Iowa. I'll go to Minneapolis or Chicago or something to see them. But yeah, it was the NASA live stream, says Andy Law. That is, and Ethan and everybody, Casper and OZ, Malafan. Thank you guys. Derek, Czech Republic gang here. Yes, apparently there is a lot of you. That's so cool. David Foro, thank you so much. And adding on a different, or the same add-on, yeah. Should ULA pursue propulsive landings for Vulcan, or is it coming in too hot? And what are your thoughts about ACES? Will New Glenn and Starship decimate Vulcan? That is a loaded question there. So for those of you, so the follow-up to the Atlas V rocket and the Delta IV, they're kind of combining those two rockets and making a new, ULA is making a new rocket called Vulcan. And Vulcan will use 2 BE-4 engines. Those are the same engines that will be on the New Glenn. These are made by Blue Origin. So it's interesting they're using 2 Blue Origin rocket engines where New Glenn will be using 7. So it's a pretty good-sized rocket, but it makes you realize how big New Glenn is, that it'll need 7 on the first stage, and the Vulcan rocket will have 2. And first off, I don't think they cannot do a propulsive landing because you'd have to fire both engines, and both engines at minimal throttle settings. You know how the Falcon 9 has 9 engines and you can use just one engine to do a landing burn? And even at the minimum throttle setting with one engine, the Falcon 9 can't even hover. It has to come in and do a suicide burn and bleed off its velocity at the exact moment it touches down. So basically, if it starts its landing burn too early because its thrust to weight ratio is too high, if it stops here, that baby's going back up. That's not good. And that's because even at minimum throttle of 1 of 9 engines, its thrust to weight ratio is still too high. So Vulcan with just 2 BE-4s, and you have to fire both of them because they're in tandem like this. So if you fire just one, it'd veer off like this. So you have 2 engines. You'd have to fire both of them at minimum throttle setting with an empty rocket or a nearly empty rocket would be like it'd be like 40 Gs or something just to stop on a dime. And they won't be propulsively landing, but they do have the ACES recovery system, like you mentioned, which is where they plan to detach the tank and remove basically the engines and the thrust structure, have those separate, and then inflate a heat shield. And don't forget also Vulcan and Atlas V, they are way further downrange. They do a lot more work than the first stage of a Falcon 9. So they're already going about twice as fast, I believe, as a Falcon 9 or even like a Falcon Heavy Center Core. They're quite a bit beyond that, a lot faster. So to do a reentry of the whole stage propulsively would require a lot more fuel. You can't do the propulsive landing. So I think their ACES system is smart. I just really wish that they had implemented it from the get-go. That when Vulcan flies for the first time, that's built into it right away. And ACES is their upper stage reuse. Smart reuse is their first stage. So they do have 2 plans for reuse. Their plans are eventually to reuse the upper stage, but that's normally hard to do because the fuel of the upper stage is cryogenic. It's liquid oxygen and liquid hydrogen, right? So in order to keep that, it tends to bleed off because liquid hydrogen is very, very, very cold. It's near absolute zero. And in space, even when it's well insulated, it'll tend to bleed off. And as it warms up, you lose, I think it's a couple % a day or something like that in space. So they've developed a system that keeps it pressurized and keeps it cold by having a small internal combustion engine, literally a piston engine that uses just a tiny bit of fuel and oxidizer to keep the tanks pressurized and keep it at operating pressure so it doesn't bleed off. So they can extend, this is a long rant, sorry, so they can extend how long the Centaur, or I don't know if it's still Centaur, it's not going to be Centaur anymore. It'll be the ACES upper stage, I think. So they can do the ACES, keep that up in space, and then they could actually dock to each other and refuel and end up with a full stage. So say you have like a payload that needs to go to Jupiter, and you get up there with you're almost out of fuel with your upper stage, you could dock with another upper stage that's already, that was used for a mission that didn't utilize nearly all of the fuel, and it's sitting there with about, I don't know, a third of your fuel. you top off that stage again, get rid of that empty stage, and you actually take off and go towards Jupiter with using a lot smaller rocket than you initially did. And I think that's a cool idea. I think I would like to see more of that. The infueling of an upper stage, because upper stages are already up there. You have all that mass, you have that engine, you have all that stuff up there. It'd be cool to start seeing more and more systems being reused like that. So, yeah, please go. Please go to Utrecht instead of Amsterdam, Netherlands. Well, I'd probably go to Amsterdam. I really like Amsterdam. It's a beautiful city. Yeah. So tune in with me tomorrow, guys. I'll be doing a live stream from the causeway, of only about 2.5 miles, 3.5-ish, 4 kilometers or whatever away from the Starlink mission tomorrow. Be sure when you guys, if you want, I do have one more. I noticed this morning. I still have one more Falcon Heavy Premium canvas. If you guys want something awesome for your wall, this is really big. Don't let the size fool you. This is 20 inches by 30 inches, so that's 50 by 75 centimeters. This is a big print, like this size on your wall, or that, almost that size. I don't know, around the two. It's a large print, premium canvas print. You can take 10% off today to get this last one for the next 24 hours if you use Launch Day. I changed the code. It's all one word now, Launch Day. All lowercase, Launch Day. 10% off of this. You can also get 10% off of this shirt, the shirt that I'm wearing, the pointy end up, flamey end down shirt. Take 10% off today by using the coupon code Launch Day. So yeah, if you guys want a chance to get that. And don't forget, I also have the rapid unscheduled discount section too. If you guys want really good deals on some leftover inventory in my shop too, click on that RUD section, the rapid unscheduled discounts, and you can get some really good deals on my merchandise. That of course helps me continue to do what I do. And just wait till you see what I'm doing. Literally, I cannot wait to show you. 2020 is going to be an awesome year. And that should be a clue, actually, 2020. Keep that in mind. There's going to be some really, really, really cool things. So, yeah. Russell says, Cedar Falls, small town, Iowa. Ha! And you don't think that's small? It's like 40,000 people. That's pretty small. You don't think that's small? I think that's pretty small. Okay, and when is the new album dropping? Okay, I promise myself and you guys someday, when I get a little more settled, which I think will be in the next month or two, I'm going to take a week to myself. I'm going to go into a high-end studio or something, and I'm going to master and mix like 2 full albums and get them ready. I promise. Keep bugging me about it. I don't know when that'll happen, but yeah, it'll happen someday. Oh, any more questions, guys? I'm going to get torn down here and get set up for tomorrow for the Starlink mission, again, live in person. It'll be really fun. So 40,000 is huge. I don't know if 40,000 is huge. 40,000 is just like a town. It's like a normal town. You guys are crazy. But thank you guys so much for tuning in. I had a really good time. And if you want to help support what I do, again, go to everydayastronaut.com/shop. Check it out. Again, we only have one more of those premium canvases in stock, but you can also get 10% off of this shirt, pointy end up, flamey end down, baby, by using coupon code Launch Day at checkout. So give that a little look, and let me know what other questions you guys have. I'm going to make sure that my whole internet stopped here, so hopefully you guys are still seeing me okay. So yeah, so thank you guys, and if you want to support what I do, consider becoming a Patreon member by going to patreon.com/everydayastronaut, where you'll gain access to our awesome Discord channel full of the coolest people that I know. You guys are awesome. And you can also gain access to our subreddit as well as our exclusive live streams as well. So stand by Discord. I will be doing that next week for sure. We will have the Patreon live stream. I'm getting a much more settled place for a little bit here. So I'll tell you all about it. So yeah, thanks guys. You guys are awesome. Thanks for tuning in. Stay tuned on Twitter and Instagram and stuff like that. Everyday Astronaut, you can find me. And I'll be giving you guys some fun updates on a lot of the cool things going on in the future. So, all right, guys, I think that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Bye, everybody.